Look up at the night sky. Those tiny points of light might seem eternal, like they've always been there and always will be. But that isn't true. Every single star in the universe is living through a life cycle. They are born, they age, and eventually they die. So how exactly does a star live and die? To understand that, we have to go back to the very beginning. Every star begins inside something called a nebula. A nebula is a massive cloud of gas and cosmic dust floating through space. Over time, gravity slowly starts pulling these particles closer together. As more matter gathers, pressure builds, and the temperature at the center begins rising higher and higher, until eventually it reaches nearly 10 million degrees Celsius. At that point, something incredible happens. Hydrogen atoms begin smashing together. This process is called nuclear fusion. And just like that, a new star is born. After birth, a star enters the longest and most stable phase of its existence. Scientists call this the main sequence. During this phase, the star continuously fuses hydrogen into helium deep inside its core. This fusion releases enormous amounts of energy. But here's the interesting balance. Gravity is constantly trying to crush the star inward. At the same time, fusion pushes energy outward. These two forces perfectly balance each other. As long as this balance remains, the star stays stable. Our sun is currently in this stage, and it has been here for about 4.6 billion years, but nothing lasts forever. Eventually, the star starts running out of hydrogen fuel. This is where aging begins. As fusion slows down, gravity starts winning. The core begins collapsing inward. This sudden compression causes temperatures to rise even further, and as a result, the outer layers begin expanding outward. The star grows larger, much larger, and transforms into what scientists call a red giant. In around 5 billion years, our sun will expand so much that it may swallow Mercury and Venus completely. And Earth won't be doing great either. If a star is relatively small, like our sun, its ending is surprisingly peaceful. As the star becomes unstable, it begins shedding its outer layers into space. These glowing clouds create something beautiful called a planetary nebula. At the center, the leftover core remains behind, a tiny, extremely dense object known as a white dwarf. Even though it's roughly the size of Earth, it contains nearly the mass of an entire star. And slowly, over billions of years, it begins cooling down, its light fades, and eventually it becomes dark forever. But larger stars follow a completely different path. Massive stars burn through their fuel much faster, and when their core finally collapses, the result is catastrophic. A gigantic explosion called a supernova. For a short time, a single exploding star can shine brighter than billions of stars combined. But even then, the story isn't over. After the explosion, if enough mass remains, the star collapses into a neutron star, an object so dense that a single spoonful of its material would weigh billions of tons. And if the star was even bigger, gravity wins completely. Everything collapses inward, and a black hole is born, a place where not even light can escape. But here's the strangest part of all. The carbon in your body, the oxygen you breathe, the iron in your blood, none of it existed when the universe began. These elements were forged deep inside stars and scattered across space when those stars died, which means long before Earth existed, an ancient star lived its entire life, exploded, and left behind the atoms that would eventually become you. In a very real sense, you are made of stardust. And one day, our own sun will join that same story. The universe is constantly creating, destroying, and beginning again. And every shining star above you is simply somewhere in that journey.